एक पेश रहा था उसकी रिफ्लेक्शन तो नहीं आएगी ना
लाइट
बंद कर दो ब्लिंक करेगा
जिसके बाद अभी फाइनल केस का मतलब
चलता है चलता रहेगा
उसको वहाँ से कह रहा हूँ खाना शुरू आवाज़ आ रही है इसका आवाज़ आ रही है
इसे बंद करके कि फिर कैसे चलेगा तो
आवाज़ बहुत आ रही है क्या करें
गर्मी में कैसे बैठेंगे
रात को फाइनल केस कर नहीं सकता
तो इसे बंद करो पहले फिर इसी को चलाओ
इसका
एक लाइट बंद करेंगे तो क्या होगा ये
मल्टीमीटर की
एक लाइट बंद करिए वाली पंखे के ऊपर वाली
ना सर
ना दूसरी हाँ तो ठीक है
हाँ 16:9 के रेशो में नितिन देखिए इसको 16:9 के 16:9 के रेशो में डालिए पीपीटी को हाँ ठीक सर देख एक मिनट मैं देख रहा हूँ कर रहा हूँ कहाँ पर होगा सर जूम कहाँ पर होगा बैकग्राउंड में ठीक है हो गया सर कर दिया इसको पूरा कर इसको पूरा कर अरे लिंक भेजना पड़ेगा सर दोबारा मुझे लग रहा है इसको चेंज दोबारा भेजना पड़ेगा देखो दोबारा शेयर करना पड़ेगा अश्लेष जी तो बैठे हुए कह रहे मैं छोड़ूंगा नहीं किसी को।
यूपीएससी में सब जाते हैं।
अंकुर भाई को भेजना है ना मिथुन जी, भेज दिया मैंने, दोबारा लिंक भेज दिया, अभी करवा लीजिए। ठीक है सर, अब बता दें कब स्टार्ट करवानी। लाइट वगैरह ठीक है सब? थम्स अप करूं? ठीक।
Good morning, learners and viewers. Welcome to the session of Quantitative Analysis for Managerial Applications, MMPC 5, under MBA program. I am your academic counselor, Ashlesh Saxena. Yesterday, in our session, we discussed about collection of data, presentation of data, and measures of central tendency. Moving further, at the end of my session, I had a brief discussion or introduction to the fourth part, that was measure of variation and skewness. So continuing with that, we will move forward, and I will be revising the last part of it, that is the beginning of your measures of variation and skewness. Significance, what is the significance of measuring variation? Measuring variation is significant for some of the following purposes. Measuring variability determines the reliability of an average by pointing out as to how far an average is representative of the entire data. Another purpose of measuring variability is to determine the nature and cause variation in order to control the variation itself. Thirdly, a measure of variation enables comparison of two or more distributions with regard to their variability. What are the properties of good measure of variation? A good measure of variation should possess, as far as another purpose of same properties is to determine measure of the nature and cause variation. Following are some of the well-known measures of variation, which provide a numerical index of the variability of the given data. First one is range, second one is average or mean deviation, third one is quartile deviation or semi-interquartile range, and the fourth one is standard deviation. Range, it is the difference between the highest and the lowest value of the distribution. For example, if we take numbers such as 2, 3, 4, 5, 6, 7, 8, 9, 10, so we see that the highest number is 10 and the lowest is 2. That means we can say that its range is 8. Its range is the simplest measure of variability to compute. However, it has limitation, it does not use all the data. If the sample size increases, the range can increase, but the range can never decrease. For example, if we take 2, 3, 5, and 10, the range will be 8, 10 minus 2. And if we take numbers 2 to 10, again the range is 8. The range does not give any information about the nature of distribution of the values. The next part is the coefficient of range. It is highest minus lowest upon highest plus lowest. Next is quartile deviation. Quartile deviation is also known as interquartile range and is computed by taking the average of the difference between the third quartile and first quartile. That is, we can say that quartile deviation is equal to Q3 minus Q1 upon 2. Quartile deviation, the relative measure corresponding to quartile deviation is called coefficient of quartile deviation. That is, coefficient is calculated as Q3 minus Q1 upon Q3 plus Q1. The quartile deviation is superior to the range as it is not based on two extreme values but rather on middle value, that is the 50% of the observations. Another advantage of quartile deviation is that it is the only measure of variability which can be used for open-end distribution. The disadvantage of quartile deviation is that it ignores the first and the last 25% of the observations. Then comes your average deviation. The measure of average or mean deviation is an improvement over the previous two measures in that it considers all observations in the given set of data. This measure is computed as the mean of deviations from the mean or the median. All the deviations are treated as positive regardless of the sign. That is why we take the mod value. Average deviation, if in case of mean, is summation of mod of x minus x bar upon n. And in case for, if it is for median, it is summation of x minus x median, x minus median upon n. There is an advantage in taking the deviations from median because the sum of the absolute values, because we are ignoring plus minus signs, or median is median. In actual practice, however, arithmetic mean is more popularly used in computation of average deviation. The relative measure corresponding to the average deviation is called as coefficient of average deviation. If average deviation has been computed for median, the coefficient of average deviation shall be obtained by dividing the average deviation by median. And for mean, it has to be divided by mean. Although the average deviation is a good measure of variability, its use is limited. If one desires only to measure and compare variability among several sets of data, the average deviation may be used. The major disadvantage of average deviation is its lack of mathematical properties. This is more true because non-use of signs in the calculations makes it algebraically inconsistent. Now we move on to standard deviation and variance. Standard deviation and variance measures variability about the mean. Standard deviation is used in another statistics as and is the most stable of the variability indices. If one reports the mean as the measure of standard tendency, then the standard deviation is also reported. The standard deviation is good for interval or ratio data. However, the standard deviation is affected by extreme values. Approximately 68% of the measurement data will fall within one deviation of the mean, and 95% falls within the two standard deviation, that is 1.96, and 97.7%, that is almost 100%, falls within the three standard deviations. The concept of standard deviation was introduced by Carl Pearson way back in 1893. Accordingly, as per the data is there, we use different formulas such as if standard deviation's basic formula is sigma is equal to under root summation of x minus x bar whole square by n, when n is the individual observations. And for group frequency, that means if we have frequency in the table, that means in that case we have to use the formula under root summation of the product of frequency and square of the deviations from the mean divided by n. And this formula can further be modified, and it can be written as summation fx square upon n minus summation fx by n whole square. If the data is big and the frequencies are big, then that means we have to use this formula where we have to assume. In that case, we have to calculate the d. The d is basically calculated as x minus a by I, and it is multiplied by f. Similarly, in the case, the x is being replaced by d, and it is being multiplied by the difference, that is I. Variance is the square of standard deviation. Now we take up an example to understand how this mean and standard deviations are calculated and how the formulas are used. This is basically a problem which is related to library membership of children in different age groups, and we are supposed to find mean and standard deviation of the membership fee. So we have given three columns to us: the age group, membership fee, and the number of children. We will be using 1 and 3. Now we have to calculate the mean. We have initially we will start with, we have to multiply f into x, that is the cost, with number of children, and for the first value it will be 3, 30 into 10, that is 300, 40 into 8, 320. Similarly going down, and in the last column we will be finding fx square, that is similarly 30 square is 900, 900 into 10 is 9000, and similarly we will be calculating all the values, and in the last we will be summing up summation f, summation fx, and summation fx square. The mean will be summation fx upon n, so that will be 1290 divided by 30, which comes out to be 43. And for the standard deviation, we will be using the formula summation fx square upon n minus summation fx upon n whole square. Putting up the values, we get 12.1518. Moving further, now comes coefficient of variation. For distributions having the same mean, the distribution with the greatest standard deviation has the greatest variation. But when considering distributions with different means, decision makers can't compare the uncertainty in distribution only by comparing standard deviations. For that, the coefficient of variation is used. That is, the coefficient of variation for different distributions are compared, and the distribution with the largest coefficient of variations value has the greatest relative variation. It is calculated by sigma upon x bar into 100, that is CV, that is coefficient of variation. Next part is skewness and kurtosis. This skewness refers to a symmetry of a distribution. Symmetry means that for a given deviations from a central value, there are equal number of observations on either side. If a distribution is skewed, it will have a longer tail either towards left or towards right. Thus, we can say skewness is a departure for symmetry. In a symmetrical distribution, mean, median, and mode are equal. If a distribution has long right tail, it is positively skewed, and if it has long left tail, then it is a negatively skewed. With this, we can see the difference between the three values. The first diagram depicts symmetrical value. That means we can see that 50% of the things are on the left side and the 50% are on the right side. If the graph is inclined more towards the right, it is positively skewed, and if it is more inclined towards the left, more part is exposed on the left, so it is negatively skewed. For positively skewed, mean is the maximum value, and we can see that mode is less than median is less than mean. And for negatively skewed data, mode is greater than median and median is greater than mean. Now we move on to the coefficients of skewness. Carl Pearson suggested a measure of skewness based on mean, median, and mode. We can see three formulas over here. First one is x minus mo upon sigma, which can be written as mean minus mode upon standard deviation. It can further be modified as q3 plus q1 minus 2 times of q2 upon q3 minus q1. Basically, this depends upon what we are calculating in the numerical. And if simple, mean and median and standard deviations are given, so we can say that coefficient of Carl Pearson is given by 3 times the difference of the mean and median divided by standard deviation. Now, depending upon the value what we get after the calculation, if Sk is greater than 0, the distribution is positively skewed. If it is less than 0, it is negatively skewed. And if Sk comes out to the 0, so that means the distribution is symmetrical. There is a formula in terms of quartile and median. This formula was given by Bole, and this is normally written as Q3 plus Q1 minus twice of median divided by the difference of third quartile and first quartile. Now we will be calculating coefficient of skewness by applying Carl Pearson formula. So the problem is given to us, the profit in thousands and the number of the companies are given to us. So we have to calculate the coefficient of skewness by the help of Carl Pearson formula. So we will convert this data into this form. So column number 1 and column number 3 were given to us. Initially we have to start with the midpoints. That means we have to calculate the mid value. Mid value is calculated as the sum of 10 plus 12 divided by 2. That comes out to be 11. Now the difference between these class interval is 2. So we will be adding to all these numbers till 23. Now we have to count the number of elements in column number 1. So there are 7. So at the center one will be the 16 to 18. We will be assuming it has to be 0. And similarly, what we discussed in our earlier session, so we will be putting minus 1, minus 2, minus 3 at the top, and below 0 we will be placing 1, 2, 3. It is similar to as calculating x minus 17 divided by 2. Then we will multiply FD. So we will get 7 into minus 3, that is minus 21. 15 into minus 2 minus 30. Similarly, we will be calculating all FDs, values of all FDs. And in the last column, we will be calculating FD square. And at the last, we will be computing the summation. N will be 100, summation FD is minus 9, and summation FD square is 250. First step will be to calculate its mean. The mean is x bar equal to a plus summation FD upon n into I. Here, a is 70, summation FD is minus 9, n is 100, and the I is the difference between 12 and 10, that is 2. After calculating, we get 16.82 as its mean. Now we move on to mode. Mode is calculated by the formula L plus D1 by D1 plus D2 into Y. So here the maximum frequency value is 25. Similarly, we will be using all these values 18 plus 5 upon 5 into 15 into 2. And the mode comes out to be 18.5. Now we move on to standard deviation. Formula for standard deviation was summation ft square upon n minus summation ft square upon n into I. After putting up the values, we get 3.1634. Now we are having mean, mode, and standard deviation. So we will be using the formula of mean minus mode upon standard deviation. Putting up the values, we get minus 0.5310. That means it is negatively skewed. Hence, there is a greater concentration towards the higher profits. So this is the conclusion what we have drawn after calculating up the coefficient of skewness. Now we will be using Wallace method to calculate a value. So this is the data which is given to us. For quartile, this Wallace method, we have to calculate Q1, Q2, Q3. So for calculating Q1, Q2, Q3, we have to calculate cumulative frequency. Similarly, you can see that below 50, number of companies are 8, and in the cumulative frequency column, we will start with 8. Coming down, we will be adding 12 plus 8, that will be 20. 20 plus 20 will be 40. 40 plus 25 will be 65, and 65 plus 15 will be 80. When you are going to add the number of the companies, we will get the same value as 80. Now moving further, we have to calculate Q1. Q1 is, first of all, we have to find n by 4th observation. That is the 20th observation, and which lies in 50 to 60 class interval. We have, for calculating Q1, we have to use the formula L plus n by 4 minus PCF upon F into I. So L will be the lower limit, that is 50. N by 4 is 20. Cumulative frequency of the preceding class is 8, and the difference, the frequency of the Q1 class is 12 into 10, the difference between 60 and 50. We get Q1 as 60. Now Q2 is similar to median. We will find out n by 2th value, that will be 40, which lies in the class interval 60 to 70. And similarly, we will be calculating Q2, which is the median, and its value comes out to be 70. For the Q3, we have to find the size of 3n by 4th observation. That comes out to be 60th observation, which lies in the class interval 60 to 80. Putting up the formula, Q3 is equal to L plus 3n by 4 minus PCF upon F into I. We get its value at 78. And by applying the Wallace formula, that is Q3 plus Q1 minus 2 times of median upon Q3 minus Q1. After putting up the values, we get the coefficient of skewness for Wallace as minus 0.11. This value of coefficient of skewness indicates that the distribution is slightly skewed to the left, and therefore there is a greater concentration of the sales at the higher values than the lower values of the distribution. This was by Wallace method. And by Karl-Pearson formula, the value of coefficient of skewness indicates that the distribution is negatively skewed, and hence there is a greater concentration towards the higher profits. Then comes quartile deviation or semi-interquartile range, that is calculated as the difference of Q3 minus Q1 divided by 2. And the coefficient of quartile deviation is calculated as Q3 minus Q1 upon Q3 plus Q1. The quartile deviation is superior to the range as it is not based on two extreme values, but rather than the 50% of the observations, because it is around the median class. Another advantage of quartile deviation is that it is the only measure of variability which can be used for and open-end distributions. The disadvantage of quartile deviation is that it ignores first 25% and the last 25% of the observations. Then comes your average deviation. Average deviation is summation of x minus x bar upon n. If we are calculating deviation from mean, and if we are calculating deviation from median, then we use the formula summation of mod value of x minus median divided by n. Since we are ignoring plus minus signs, so the value of the difference, that is x minus median, is the minimum. The relative measure corresponding to the average deviation, called the coefficient of average deviation, is obtained by dividing average deviation by a particular average used in computing the average deviation. Coefficient of average deviation is AD by median if we are considering median, and if we are considering mean, then we have to use AD by mean. The average deviation is a good measure of variability, but its use is limited. The major disadvantage of average deviation is its lack of mathematical properties because we are ignoring plus minus signs. Now, we move on to block 2, that is probability and probability distributions, which consist of your 4 units: basic concept of probability, discrete probability distribution, continuous probability distributions, and decision theory. So we will start with basic concept of probability. The thing is that what is meant by probability? Probability is concerned with random experiments. Data demands an inference to be drawn, and statistical inferences are never certain. Statisticians would be prompted to use prefixes or suffixes as likely or almost likely. Probability and its concept are thus very important to interpret the inferential statistics. The theory of probability is a study of random experiments. In a random experiment, set of all possible outcomes is always known, but it is not possible to predetermine the outcome. For example, probability of a coin toss resulting in either heads or tails is 1. The probability of a coin tossing resulting in head is 0.5, that is 1 by 2, because the toss is equally likely as a result in tails and there is only 2 possible outcomes. Probability is basically a relation between or a ratio between the favorable cases upon total number of cases. Probability deals with calculating the likelihood of a given event's occurrence, which is expressed as a number between 1 and 0. An event with a probability of 1 can be considered a certain event, and an event with a probability of 0 can be considered as an impossible event. In other words, with the help of probability, we can assign a measure to the uncertainty with the occurrence of each possible outcome of a random experiment. An interesting question is probability of getting a red card from a pack of cards. As we are aware that there are 52 cards in a pack of cards, and there are 26 red cards and 26 black cards. Here, the probability of getting a red card will be 26 by 50, because there are total number of cases are 52 and the favorable cases for red card is 26. The probability of getting a red card from a pack of cards will be 26 by 52, which is half. Now we move on to some basic concepts which will be used in problems related to probability. Experiment. The term experiment is used in probability theory in a much broader sense than in physics or chemistry. Any action, whether it is the tossing of a coin or measurement of a product's dimension to ascertain quality or the launching of a new product in the market, constitute an experiment in the probability theory terminology. Sample space. The set of all possible outcomes of an experiment is defined as a sample space. Each outcome is thus visualized as a sample point in the sample space. In case of a toss of a coin, head or tail, two things are there. That means its sample space will be head and tail. Event. An event in probability theory constitutes one or more possible outcomes of an experiment. Thus, an event can be defined as the subset of sample space. Or we can say in short that an experiment is a toss of a coin. Sample space is either tail or head, that means it is represented as T, H, and the event getting a tail on a toss. Probability is defined in many ways. It can be through this classical definition of the probability or axiomatic definition of probability. Before defining probability, several other definitions are needed to be understood, such as what is random experiment. An experiment or trial whose outcome is not perfectly predictable, but for which the set of all possible outcomes is repeated trial is known. That is toss of a coin. Outcome will be head or tail. A random variable is an assignment of numbers to possible outcomes of a random experiment. For example, considering toss of 2 points, the number of heads showing when the coin lands in the random variable. When we are flipping up a coin, whatever comes, it has to be noted. Let the number of tails be t. The random variable assigns the value number 0. That means t. For one tail, it will be t head, and for two heads, it will be h. Outcomes and events. The outcome space is the set of all possible outcomes of a given random experiment. The outcome space is often denoted by capital letter S. That means, taking up an example of tossing of a coin, your sample space will be S is equal to within bracket T, H. An event is a subset of outcome space, and the event is determined by a random variable. Outcomes are the set of all possible results of a random experiment. What are exhaustive events? Exhaustive events are set of events in a sample space such that one of them compulsorily occurs while performing the experiment. In simple words, we can say that all the possible events in a sample space of an experiment constitutes exhaustive events. For example, while tossing an unbiased coin, there are two possible outcomes, head or tails. So these two outcomes are exhaustive events, as one of them will definitely occur while flipping the coin. Disjoint or mutually exclusive events. Events are disjoint or mutually exclusive if the occurrence of one is incompatible with the occurrence of the other. That is, if they can't both happen at once, if they have no outcome in common. Equivalently, two events are disjoint if their intersection is the antecedent. Independent events. Two events A and B are statistically independent if the chance that they both happen simultaneously is the product of the chances that each occur individually. Or notice that one event has occurred does not give any information about whether the other event has occurred too. For example, getting ahead on the first row and getting ahead on second row are two independent events, equally likely events. Two events are said to be equally likely if the occurrence of none of them is expected in preference to others. That means they have equal probability of occurring. When a toss of an unbiased coin is there, probability of getting a head will be 1 by 2, and probability of getting a tail will be 1 by 2. That means the probability of getting either a head or a tail in a single toss of a coin is same. So it is equally likely events. If we roll up a die, probability of getting 1 is 1 by 6, probability of 2 is 1 by 6. All the values are same. That means tossing of a die and getting up the outcome are an example of equally likely. However, the probability of drawing one red ball in a bag of three blue and two red balls is 2 by 5. And the probability of drawing a blue ball from a bag of three blue and two red balls is 3 by 5. We can clearly see that these events are not equally likely to occur. Now, the mathematical definition of probability. If n is the number of equally likely, mutually exclusive, and exhaustive outcomes of a random experiment, out of which n outcomes are favorable to the occurrence of an event, then the probability that A occurs is denoted by PA, and it is given as number of outcomes favorable to A upon number of exhaustive outcomes. Mathematically, it is equal to m by n. Or, in other words, we can say that probability of an event is number of favorable cases upon total number of cases. All these approaches, however, share the same basic axioms. These axioms are fundamental to the probability theory and provide us with a unified approach of probability. Now, what are these axioms are, what we have learned, what we have understood. The probability of an event is written as PA, must be a number between 0 and 1, and both these values are inclusive. That means 0 is less than equal to probability of A less than equal to 1. Secondly, the probability of occurrence of one of the other of all possible event is equal to 1. As S denotes the sample space of or the sets of all possible events, we write PS equal to 1. Thus, in tossing a coin, probability of head or a tail, when we club them, it will be 1. If two events are such that occurrence of one implies that the other cannot occur, then the probability that either one or the other will occur is equal to sum of their individual probabilities. That means we can say that in tossing up a coin, probability of getting a head is 1 by 2, and probability of getting a tail is 1 by 2. When we are going to add these two probabilities, we are going to get a sum of 1. Now we take up a problem which is related to how to solve, how to analyze things in a complex situation. Suppose in a survey it was found that 21 people liked product A, 26 liked product B, and 29 liked product C. And if 14 people liked product A and B, 12 people liked product C and A, and 14 people liked product B and C, and 8 liked all the three products. We have to find how many liked product C only. The problem itself seems to be a very complicated one. How to analyze and how to get the result. So with this, we will be using our set relation theory. We will define A, B, and C with a set of people who like product A, product B, and product C. And according to the question, NA will be 21, NB will be 26, and C will be 29. And both A and B, number of people liking product A and B is 14, C and A is 12, B and C is 14, and liking all the three is 8. So we will be converting this data into a Venn diagram. So this diagram, what we see over here, is a Venn diagram which is showing interrelation between the three products and intersection part of A and B. The sum is 6 plus 8, that is 14. And for intersection of C and A is 12. And for intersection of B and C is 14. And the common part, which is both to A, B, and C, is 8. And we can see that the number of people who like product C only is 29 minus 4 plus 8 plus 6. So we are taking out these three values. We get as 11, which means that there are only 11 people who like product C. We take up another example, which is related to now probability. We consider your locality where there are 5,000 people residing. 1,200 are above 30 years of age and 3,000 are female. Out of the 1,200 who are above 30, 200 are female. Suppose after a person is chosen, you are told that the person is a female. What is the probability that she is above 30? So we see over there are two conditions in this problem. A, we assume that there is a person chosen is above 30 years. And for B, we take a person chosen is a female. If we go through the problem once again, we find that problem is focused on the event A, given that B has occurred. In that case, we have to denote the event by A by B, and we have to calculate the value of probability A by B. Out of 1,200 persons who are above 30, 200 are females. Here, out of 5,000 people in the locality, 200 possesses the characteristics of being female as well as above 30. The event E and B can be defined as AB, and the event that the person is both a female and above 30 years of age. In that case, we have to calculate PA, which comes out to be 1,200 by 5,000, PB 3,000 by 5,000, and probability A and B both has occurred, that will be 200 by 5,000. To find the probability that given a female has been chosen, she will be above 30. We see out that 3,000 females in the total population, only 200 females are above 30. In that case, PA by B will be 200 by 3,000. Or otherwise, we can see that how this is calculated. The PA by B is what we get is 200 by 3,000. It can be calculated as 200 by 5,000 into 5,000 by 300. Mathematically, it is PAB by PB. In axiomatic approach, probability is introduced as a function of outcomes of an experiment under certain restrictions. These restrictions are called axioms of probability. Axiom 1, the probability of an event is a non-negative real number. That means it will lie between 0 and 1. The first axiom implies that the probability of an event is a non-negative less than or equal to unity. Axiom 2 is The second axiom implies that the probability of an event that is certain to occur must be equal to unity. Now the thing is that how do we assign probabilities to the events? There are few theorems on probability which can help us you in mathematical treatment of the subject of probability. We have seen the earlier problem also. Probability phi is zero where phi is a null set. PA complement means 1 minus PA. If there are two events A and B, then we can find out the probability of PA intersection B as PB minus PA intersection B. And your addition probability theorem is PA union B is equal to PA plus PB minus PA intersection B. Now comes the conditional probability theorem. For any two events in a sample space S, the probability of their simultaneously occurrence is given by PA intersection B, which is the product of PA into PB by A, or which is equal to PB P A by B, where PB by B by A is the conditional probability of given B given that A has already occurred. Then comes multiplicative theorem for independent events. If two events A and B are independent, then the occurrence will be given by PA intersection B, which is equal to product of the both probabilities, PA into PB. The most important part of this probability unit is the Bayes theorem. Before stating the theorem, it is imperative to know about prior and posterior probabilities. Prior probability are those probabilities which are assigned to events on the basis of conditions, past experience or judgment. And posterior probabilities are these are the revised probabilities in the light of some additional information. We will see how these two things are depicted in a problem. If the Bayes theorem states that if A and B are two mutually exclusive and collectively exhaustive events, and C is another event defined in the context of the same experiment, then the given value of PA, PB, PC by A, and PCB by under that condition, probability condition will be PA by C is equal to PC by A into PA upon summation of both the probabilities. That is PC by A into PA plus PCB by into PA. And similarly for probability B by C, the same thing can be done or can be calculated. Now we take up an example to understand what was presented in the formula. Suppose a car manufacturing factory has two plants, X and Y. Plant X manufactures 70% of the cars, and plant Y manufactures the remaining 30%. 80% of the cars of plant X and 90% of the cars of plant Y are stated or rated of standard quality. A car is chosen at random and is found to be of standard quality. So we have to calculate what is the probability that it came from the plant X. Here, there are two plants, X and Y. They are manufacturing cars. Plant X is manufacturing 70% of the car, and plant Y is manufacturing 30% of the cars. Out of the total production, plant X produces 80% of car of the standard quality, and as far as plant Y is concerned, it produces 90% car of standard quality. Now, a car is chosen from the random lot and it is found to be of standard quality. Now, we have to calculate what is the probability that it came from the plant X. Mathematically, how it is presented. Let E be the event that the car is of standard quality. If it came from X, plant X, so let it be B1. And if it comes from plant B, let it be B2. Now, we will calculate what is the probability of manufacturing, first of all, manufacturing of the manufacturing capacity of the plant. For PB1, it will be 70 by 100, which will be 7 by 10. For PB2, it will be 3 by 10. Now, the next step is finding the probability of a car that is of standard quality and it is being manufactured by plant X. In that case, its probability will be PE by B1 and it will be 80 by 100 because 80% are manufactured by plant X. It comes out to be 8 by 10. Similarly, for plant Y, it will be probability P by B2, which will be 90 by 10. Now, we have to calculate the probability that the car chosen was of standard quality and it is from plant X. That means we will calculate P B1 by E. For that, probability of plant B1 into probability of getting a standard car divided by probability of selecting the car by selecting the plant and its probability plus the second. In the denominator, both two things will be added up. Putting up the values, we get 7 by 10 into 8 by 10 divided by 7 by 10 into 8 by 10 plus 3 by 10 into 9 by 10. Now this, what we get is 56 by 83. Similarly, if we want to calculate for the other part, other plant, Y, so we will just be replacing the numerator by 3 by 10 into 9 by 10, but the denominator will remain the same. And it will be 27 by 83. Now, we move to next part, that is discrete probability distribution. It is further extension of your probability analysis. In this, if all the possible outcomes of the experiment together with their chances of occurrence were made available. First step. If betting on heads, you find that a toss of 3 coins may result in 0, 1, 2, or 3 heads with the respective probability of 1 by 8, 3 by 8, 3 by 8, and 1 by 2, which were 2 outcomes out. This representation of all possible outcomes and their probabilities is known as probability distribution. Suppose you are interested in number of heads of in a tossing of 12 coins. For this case, we have to apply a discrete probability distribution. And discrete probability distribution can be used in decision making. Outcomes of toss of 3 coins were expressed in the terms of number of heads. H can assume the value. No head comes, 1 head comes, 2 head comes, or 3 head comes. And the corresponding probability will be calculated. This uncertain real value H, which assumes different values depending on the outcome of an experiment, and to each of whose value a probability assignment can be made. This is known as random variable. A discrete probability distribution counts occurrences that have countable or finite outcomes. This is in contrast to a continuous distribution, where outcomes can fall anywhere on a quantum. Common example of discrete distribution includes binomial, Poisson, and Bernoulli distribution. We will be discussing. A discrete probability distribution function has 2 characteristics. Each probability is between 0 and 1 inclusive, and the sum of the probabilities is 1. Discrete events are those with a finite number of outcomes. For example, tossing of a dice or coin. For example, when we flip a coin, there are only two possible outcomes. Either you are going to get head or tail. And similarly, if you are going to toss or roll dice, so you are going to get numbers 1, 2, 3, 4, 5, or 6. It is computed using the formula mu equal to summation of xpx. We are talking about mean. Variance is sigma square and standard deviation sigma of a discrete random x are numbers that indicates the variability of x when numerous trials of the experiments take place. Here we can see that this is a typical representation for probability distribution. Suppose we are talking about number of heads, probability of getting the event is no head, that is represented by 0, 1 head by 1, 2 head by 2, and 3 heads by 3. These are the discrete values. And the respective probability distribution which comes out for getting a head, a no head is 0.125, getting a single head is 0.375, getting two heads is again 0.375, and getting three heads it's 0.125. If you are going to add all these four values, you are going to get 1. If we are going to get 1, that means it is a sure case that probabilities what we have calculated or what we have found are correct. If you are not getting the sum as 1, you have to recheck your calculations. Now we place up this into tabular form. Probability distribution for random variable. A description of a random variable along with the corresponding probabilities is called probability distribution of the random variable. If random variable of x takes the value of x1, x2, x3 till xn, and their respective probabilities are p1, p2, p3. In tabular form, we can place them like this: x, x1, x2, x3 till xn, and for probability of an event x1 is p1, p2, p3 till pn. For the above, x is given only when p1 is greater than or equal to 0, and summation of pi, that means the probabilities, is equal to 1. We move on to mean, calculating the mean and variance of random variable. In that case, we have to sum up the product of xi and pi. And for the variance, we have to use the formula summation of x square pi minus mu square. Mu is your mean, and the standard deviation is the under root of variance. Variance is defined as the expected value of the square of the difference between the random variables and its expected value. We take up an example what we have taken earlier. I was just telling it. Now I'm showing that same problem mathematically. We have to find the mean, variance, and standard deviation of the number of heads when 3 coins are tossed. Sample space are TTT, TTH, THT, HTT, TH, HT, HT. No head, 1 head, 2 head, 3 head. We will be stopping and we will be meeting tomorrow. We will be continuing with the same. रिकॉर्ड हो गया